or problem number 27. In this case, we have received the data for Mark's canoes, and we received the data for the 4 most recent periods of time, and Mark breaks his business sales into quarters based on the season: winter, spring, summer, and fall. And Mark is wanting to do a forecast for 2019. And he feels that he's going to be able to sell 5,600 canoes in 2019. But he also realizes, and you can see from the data, depending on the time of year, he knows that his sales will go up and down. In the fall, he sells fewer canoes. In the spring, he sells more, and it fluctuates depending on the season. So we will go to chapter number 4. We will go to the seasonal model. Now we have 16 periods of data, 16 data points, for 4 years and 4 each, and there are 4 seasons. Now what I have done is pre-done these, save us a lot of time. Copy and paste this, just like you can in the Excel OM from the MyOM Labs. So I've got the winter, spring, summer, fall. Now you have to be careful. I've had students go across. What they're doing is they're entering winter, 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 winter. So you have to be careful in this case to go by column. It takes the first period, the 5th, the 9th, and the 13th as the same season. So every fourth row, 1, 5, 9, and 13 will be treated as winter. And it will calculate an index for us. So what you can see here, it's just done all the calculations for us. So this is season 1 would be our first one, which would be winter. We'd have spring, summer, and fall. Now, so this tells us that spring and summer are our 2 strongest periods of time. And if you're selling canoes, that makes sense. Winter actually isn't bad. Some people will buy it during the winter, but fall is our worst because people, say don't buy it in October because they may not be able to use it till next spring, next April or May or June. Now, how do I forecast for next year? You forecast for the entire year using one of the models that we've talked about. So sorry about that. Using the moving average, exponential smoothing, weighted moving average, regression, any one of those cases. So you feel that you're going to sell 5,600 canoes for next year. So you plug that number in. That's for the entire year, and it will calculate the winter. You're going to sell 1,260 canoes. The spring, you're going to sell 1,680. The summer, you're going to sell the most number of canoes at 1,960. And then the fall, you're only going to sell 700 canoes. So you would do a forecast for the entire year and then apply seasonality to it. And you can see that winter is 90% of the average, spring is 120% or 1.2, summer is 140% of the average sales, and the fall is only half. So this will affect how many canoes you bring in for inventory. It'll affect your sales force. So you may want to have some students helping you sell canoes because spring and summer is when they're available. And they go back to school, which is good because you don't need them because you're only selling half the number that you would pay, half of the average. So this calculates how many canoes you're going to sell by, in this case, quarter or season as they have it. A lot of industries use quarters. Airline industry uses quarters. In Canada, Q1, which is January to March, is the for flights for airline because of a lot of people wanting to go south to escape our cold winters. So that's the end of this example, problem 427. And you do have to be careful how you enter the data. There are some where it will give you, say, fall. So if it did fall, you'd have to enter that in the first period of time and the fifth. So just be careful with that when you're entering the numbers. And if you enter the numbers correctly, as you can see, I have done up above, it calculates the indices, and then you simply have to put in the forecast for one complete cycle. In this case, it's an entire year.